All right. Hey guys, welcome back. We are going to do the Introduction to Graphical Limits Day 2. So for this one, instead of being given a graph and looking at limits, we are actually going to make our own graph, or we're going to look at a table of values so that we can find the actual limits. So let's start off by graphing this piecewise. This should be pretty easy after the activity that you guys did in class on Thursday. So x squared plus 4 for when x is less than 0. So we know that's going to be a parabola. And if we plug in 0, we would be at 4, and that's going to be an open circle. Okay, and we know that that's where the vertex would be, so we can use our normal parabola tricks. Go over 1 and up 1, over 2 and up 1, 2, 3, 4. And that's going to be a nice parabola shape for us. Okay. Then we also know that if x is equal to 0, that we're going to be looking at just the function x, which we know is just a line with a slope of 1 and a y-intercept of 0. So we actually just have a closed dot at 0, 0. Oh, sorry, that marker does not look very good. And then we also have a line, 3x plus 4, for when x is greater than 0. So if we plug 0 in there, we actually get 4 again. So I'm going to go ahead and just put an open circle around the open circle that we already have, and then go ahead and use our slope of 3. 1, 2, 3 over 1, 1, 2, 3 over 1. And we can make a nice line. And now that we have a piecewise function of our own, we can start looking at evaluating the limits that are down below. So if we're looking for the limit as x approaches 0 from the left, then we are looking at the purple parabola. And as x is getting closer and closer to 0 from the left, we're approaching the value 4. When we look at the limit as x approaches 0 from the right of f of x, we're looking at the blue line that we actually drew in. So that is also approaching the number 4, which means if we were asked, the overall limit as x approaches 0 of f of x would actually be 4, because on both sides, we're getting closer and closer to the number 4. This right here, though, is asking us for the function value at 0. So it's saying, hey, if I plug 0 into this function, what value do I get? And right here, that would be that orange dot, although it looks more black now, sorry. That would be that orange dot at 0. Okay. Then we want to look at the limit as x approaches infinity of f of x. So we're going to be looking at x values getting bigger and bigger. We're looking at the blue line, which is going off to positive infinity. And then if we look at the limit as x approaches negative infinity of f of x, we're looking at the purple parabola, because those are my smaller or my more negative x values. That's also going up to positive infinity. Okay. Now this next part, we're actually going to be graphing some functions and trying to evaluate the limits. So I'm not going to have you fill in anything in the buttons box over here quite yet. We're going to kind of discuss it a little bit as a class tomorrow, or when I see you in class next. But what I do want you to do is grab your calculators, and we are going to plug in this function right here. So sine x over x, and we're going to graph it. Sine x over x. Now, we could actually go to the graph and take a look and see what's going on. So if you want to, you can go ahead and hit graph, and we can take a look. Now, we would have to change the window because it's a little difficult to see things. So I usually like to go to the table instead. So I'm going to show you both. But there's our graph, and if we look at it, it does kind of look like it's approaching a value here. If we hit the trace, then we can see that it says x equals 0, and it says y is nothing. But if I go to the right, it's at 0.9961 and then 0.98. But if I go back towards over to the left, it is also looking like 0.996. So I'm thinking the value might actually be 1. I'm going to double check it with the table. So in order to do this, we're going to change the table settings. So I need you guys to hit second and then window and go to the table setup. Whatever this x value is that we're trying to approach, that's what you want your table start to be. So in this case, we want it to be 0, and that's what mine is already set at. But now the change in x, well, we want it to be really little because we're looking at the limit as it gets closer and closer to 0. So we're actually just going to make it like 0.0000, put a bunch of zeros in there for me, and then put a 1. Okay? Now we're going to actually look at the table. So hit second graph. And the first thing we notice is that if we plug in 0, we get an error. And that makes sense. We already know that. If we were to put a 0 here, that would be a big problem. But what we can't see necessarily on the graph, but we can see from the table now, is that all of these values are getting closer and closer to 0 here, and closer to 0 here, and they're all 1. Okay, so they're close to 1, because if we tried to actually plug them in, we would get really small numbers, or really close to 1, excuse me. So our value is actually 1. Okay, then we're going to do the same thing here. So let's plug in this function. So y equals x squared minus 1 over x minus 1. And now when I go to my table set, I'm going to want my table to actually start at the number 1. So hit second window, and we're going to start at 1. And right now my table change says 1e negative 7. I'm good with that. It means it's really little. Okay, so let's go to the table. So second graph to get to our table. And again, 1 gives us an error, which makes sense. Look at this function. If you plug in a 1, you'd have 0 on the bottom. That'd be a problem. But look at all the values around it, right? If I go down by 1, it says 1.00000001. Well, that answer there is 2. And even as I move a little bit farther away, it's still going to 2. And if I look at the left limit, then it's also 2. All of these values on both sides. Here's my left side, and here's my right side. All of those values are approaching the number 2, which means my overall limit is 2. All right. Now this is a little different. Take a look at number 3. It's saying the limit as x approaches infinity of this function. So infinity, we can't plug that into the calculator. Okay? But what we can do is we can plug this function into the graph. So let's do that first. The square root of 9x to the 4th minus 2x over 6x, 6x squared. Okay, and I am actually going to also do math and then go to decimal. Okay, so what we're going to want to do is we want values getting really, really, really big. So we're going to go to our table set. And instead of our table start being some specific number, we're going to do 10 and then E. To get that E, by the way, I hit second and then the comma, and it's right here in blue. We're going to do 10E, let's do 7. Okay. And our table change, we're going to do the same thing, 10. E7. Okay, and now I'm going to go to my table. And when I do that, all of these values are really, really big. And as I keep getting bigger and bigger and bigger, my y values are all 0.5 right now. Okay, so that must mean that my limit right here must be 1/2. Okay, I don't even really have to do much more. I just know that as my x values get bigger and bigger, my y values are all 1/2, which means this must be 1/2. All right, we're going to do the same thing with negative infinity now. So let's plug in this new function here. So we're going to do alpha y equals 3x to the 4th minus 5x to the 2nd all over 6x squared. And again, I'm going to, actually, you don't have to do the decimal. We can leave it alone. It's fine. But let's go to our table set. So we're going to do second window, and we're going to change our table start. So now it needs to be a negative number. So I'm going to do negative 10 E7. And again, our calculator puts it in there. I just don't want to type all those zeros, to be 100% honest. So it's easier to do 10E. And then we're going to go to our table. And now instead of scrolling to the right, we're going to be scrolling to the left because I want to be getting more and more and more negative. Okay, so as I do that, these values seem to be getting bigger and bigger. If we look, they all say E17. So that means this one right here is 8.5 times 10 to the 17th power, which means this is getting really, really, really big, which means this one right here must be going off to infinity. Okay. Now, let's look at some tables that are already made, so you don't have to actually plug them into your calculator and do them. Okay. A table of values has the given information, and we're going to take a look and see if we can figure out what's going on. So 0.99, 0.999, 0.999, 0.99999. So clearly this is getting bigger and bigger, and to me that would be approaching 1. Let's see if that's the same on the other side. So 1.00001, 1.0001. Yeah, it to me looks like these are all approaching the number 1. Okay? So based on our numerical values, we would say that the limit as x approaches 1 of f of x is, we need to look at those y values. So 1.9949, 1.9995, and as we keep going from the left, it looks to me like that's getting closer and closer to the number 2. And as we move in from the right, 2.0049, 2.0005, 2, 2. So to me, this limit would be 2. Okay, so if we want to sketch a possible graph close to x equals 1, so I'm going to just do, this is a very rough sketch, guys, okay? But I know that I need an x value of 1, and I know that on the left, I'm starting at like 1.9 something, getting closer and closer to 2, and on the right, I'm bigger than 2, which means my function must be going something like this. Now, it could be different, okay, but I do know that on the left side of 1, I'm a little bit less than 2, and on the right side of 1, I'm a little bit more than 2. So I do need to be increasing as I go. That doesn't have to be an open circle. It could be closed. We could have a closed dot somewhere else on our function as well. But the beauty of these ones is that you guys can kind of play around with it. You guys are going to do the next one on your own, and then we will compare some answers in class. All right, I hope this went okay. If you have questions, please make sure that you wrote them down, and we'll talk about them in class. I'll see you later. Bye.